Hello, good evening everyone. My name is Darrenraj Jayaseelan and my matrix number is 2010925. Well, today I'll be talking about our project title, which is Seatbelt Warning Light System and Speed Control System. This is our relation table where there will be three input, will be S1, S2 and S3. Therefore, S1 is pressure, S2 is for speed, and S3 is for belt. And the X, Y is our output. The X is known as the display or the warning light system, and Y will be the automated valve. Okay. Therefore, here you can see when at state 0, all will be as stationary, where S1, S2, S3 will be 0, and the output will be 0, where no sensor will be activated. When the S1 is 1 and the S2 is 0, while S3 is 0, the X will be 1 and Y will be 0, because the seat belt is not fastened and the car moves. So when the S2 is equals to 1 and S1 is 0, S3 is 0, we don't care because the seatbelt is not fastened. When the S1 is 1, S2 is 2, S1, and the S3 is 0, the both output will be 1, 1 because the seatbelt is not fastened, and also the car, because the car will start to calculate RPM. When it reaches 20 kilometer, it will reduce the speed. So when S1 equals to 0, S2 equals to 0, and S3 equals to 1, and the output will be XX, which is don't care. And for S1 equals to 1, S2 equals to 0, 1, S3 equals to 1, it will be don't care. So it follows for the last one also. S1, S2, and S3, 0, 1, 1. The three description will be as don't care because the seatbelt not fastened, the car move, the seatbelt is activated, and also the seatbelt activated while the car move. But for last one, when S1, S2, and S3 both, the 3 is 1, the X will be 0 and the Y will be 1 because the seatbelt is activated and the car move. The car start to move and activate the Y because it will start to reduce the speed of the car. Okay, if there is pressure and the seatbelt is activated, the display off. When the S2 speed is activated, car speed monitoring will active. Simple. Okay, you must assume that the warning will be activated when it is a desired situation. Okay, you can see here, S3 is 0, not fasten, S3 equals to 1, fasten, and S1 not moving, S2 equals 1, moving. Okay, you can repeat, and S3 is the belt. Okay, that's all for me for today. I pass this to my team member. Thank you.
Thank you, Darren. All right. Can you hear me okay? Thank you, Darren. So my name is Ryan. I'm going to talk about my state diagram. So in the state diagram, I have three stage, which is state one, state zero, state one, state two, and state three. So I would have declared that all the don't care condition won't be taken into consider into my arch line, won't be considered into my state diagram. And then what I'm going to do is this will be my state zero, this will be my state one, this will be my state three, and this will be my state two, as you can see from the state diagram. So this is how we form up, and then I would like to pass the baton back to Deehban.
Hello, my name is Deehban. My meeting number is 201090955. Now, we will presenting the table. This table, state input, state X, and set 1 and the input is that the output is output, which is XY. Okay, the first is input will be same until 111. I didn't mention the next state because the same the graph table of the output of the table, but the output, the new output is X and Y will be 0, Okay, the next row which is same, the present will change to 1 and the next will be remain and but after xy will be 0, the same of the present state. The third row also same, 1 0. The input will remain same and the present next state, next state also as the which is present state, and moving on the present state will be 1 1. The input will be same, the next state is same, but the output will be same to the present state. That's it. Next, I will go give to the Yong to present.
Okay, thank you, Deehban, for presenting the state table. I'm Yong Ting, so I would like to present how you do it from flip-flop. So by doing the flip-flop DA and DB, so how it will look like is a present state, and we're using the state table for the flip-flop input DA and DB. So we will using the present state and the next stage. Okay, first, when you see the 0 0 and the next stage is 0 0, we form the DS is 0. And then when you see the 0 and 0 and plus 1, the next step, the present state and the next stage, you can see 0 0 0 1, you can get the 1 in the DA flip-flop input. So when you get the 0 and the don't care, so it will be the don't care. So this one is the continuous that I explained. So next we will move into the connect. So how we will do the connect is just directly using the state table. We using the input S3, S2, S1, and our input ZN0 and Z1 to construct the connect. So our X output, the first output, we will get S equals to Zn0, and the next Y, we will construct our Y output, and we will get the Y equals to Zn1. So DA flip-flop input, we also using the same things that we will get the S3 bar and S1. The next is DB. The DB, we will get the connect to get the simplifications equation is x2. So that's all for me.
All right. All right. Thank you. Thank you, Yong Ting. So after all my comments has come together to explain how the circuit runs, from the relation table, from the relation table to K-map, then to the state table, and then we have finally come up with a logic circuit. This is our final logic circuit. So I would like to run a simulator to show it to how it actually runs. So this actually just now Yong Ting, my team member, has explained how the K-map comes from. So this is how you construct circuit, and then this is how you connect each other to the Z0 and Zn1. So when we go into state 0, no sensor will be activated upon looking into the K-map. When no sensor is activated, my output will be 0 0. Output will be 0 0. I'm getting a 0 0. So I'm state number 0 means I'm correct. Okay. So when I were to run my pressure S1, I'm getting state number 1. My X will be activated, which means that my warning system will be telling me to buckle my seatbelt. Now I'll proceed to stage number 2 first. Stage number 3, sorry. It means that my X and Y will be activated because there's pressure and there's speed. I'm state number 3 as how just now we have already tell that we will actually arrange our, here will be your stage 0, state 1, state 3, and then this is your state 2. So when you have 1 1, it's automatically at state 3. And then when I open all my sensors, I'm getting 0 1, okay, correcting to my output, which is at state number 2. So this is what we have to demo and show today. From the start to the end, we are successful. We can call this our mini project, the full success, and then we are getting the result that we're expecting from the K-map help as well.